Welcome to lesson 6. This is the final lesson in the series of looking at the plate boundaries. And well, this isn't a plate boundary. This is where we have like a midpoint somewhere well away from the plates, where we get the explanation of volcanoes, and it's hotspot theory. Sometimes known as magma plumes, hotspot theory. Kind of as an additional theory to why you get volcanoes, because the plate tectonics theory kind of explains where you get convergence or divergence, you can get volcanoes. But then you get, and if you remember back to that first lesson, there are quite a few volcanoes nowhere near a plate boundary. Well, this theory kind of caters for that. So just a reminder where we're looking at here. Where we go? There we go. Hotspots from mantle plumes. That's what we're looking at there. It links in with, kind of works alongside this theory here. And then if we look down here, it puts his place amongst this lot here. Okay, relatively short video. So let's crack on. So the idea of hotspot theory is that there's a fixed plume, like a jet, if you like, think of a flame in a fixed position. It's obviously not a flame, coming from the outer core in a fixed position that goes all the way through the mantle, up underneath the crust, burns its way through the crust in a fixed position, and the plate moves like a conveyor belt over the top of it. And you can see that's alluded to in the still here. So there's our plume. You'd have to go all the way down to the outer core. This constant flow of a very specific jet plume of magma coming up, burns its way through, erupts onto the seafloor, continues to erupt, large enough to form undersea volcanoes, which then become islands, and then they carry on erupting as an island. But hopefully you'd recognize the logic of this. If this plate's moving, eventually this island would move away from that hot spot. You'd stop having eruptions, and then a new one would be formed, and it's a conveyor belt, and the Hawaiian Islands are part of that hotspot island chain. And what you then get is this series of islands that kind of extend this way. They become extinct and actually become worn down, and that will be shown more clearly on the next video, the next slide. So again, just to repeat, there's our plume, there's the active volcano, and then as you can see, they move away following this chain of islands, and you can see they are getting smaller and smaller as they get worn down by, again, subaerial processes. In this instance, also a lot of marine processes as well. So they become eroded and eventually might just end up as undersea mountains. Okay, so it's continuous. And the next, and again, quite an average animation, but nevertheless it indicates some of the movement we're talking about. I think you can see there might be better video clips that I could have used for this. So a little bit sort of jerky in its motion. There you can see it there. That would be active. Hawaiian island chain is a classic example of this, and they get smaller and become worn down as they go in that direction. And you can check out some YouTube clips, which is what I'm not doing here. I'm trying to stay away from that just because of the size of the videos and whatnot. You can see there's a video clip there that you can look on the PowerPoint. And it just gives an idea of the size. It's all very, very sort of slow, takes a long period of time. But like Hawaii is one of those places that you can go to and often see eruptions, and you can see land formation and so forth. This is probably one of the shortest clips of the videos that I've done. But now what we've got here is a complete series of the boundaries, but also going to hotspot theory. And hotspot theory explains why you get volcanic islands, volcanoes, well away from plate boundaries. So it's a complementary bit of theory that kind of works alongside it. Anyway, that's it for this series of lessons, and I'll see you for lesson 7 at some point soon. Goodbye.